Hi, it's Chris Dicker here from IFM. Today we're going to go through the VNB211 and show you what it can do, how to program it, and a few other things I guess as well. So because I've got a face for radio, I'll go back to show you what we're actually looking for. So here you see the VNB211 mounted on my demo unit on my desk here. So you can see it's actually reading at the moment in velocity in RMS. So if I thump on the desk a bit, you'll see the level increasing nicely as I do that. So it's low frequency. So low frequency is used traditionally for unbalance, the VRMS, which means it goes from 10 to 1000 hertz, so low frequency things. So things like your misalignment, rubbing, cavitation to a certain extent, even though that's at a higher frequency normally, but your machine normally jumps up and down, and that's actually picked up sometimes under velocity as well. So it's good for machines like centrifuges, for one. If you don't have any protection on a centrifuge, this is a fantastic little device because you've got a history function built into it as well, which we'll go through later. You've got outputs in there so you can shut it down, of course. You've got an analog you can use as well. And the other unique thing about this unit is that you've got an acceleration mode. In fact, two acceleration modes, one for acceleration RMS and the other one acceleration in peak, which is probably more handy for you. So we'll have a look at both of those in a second. So let's go to the software now. If I click on project and create new, we'll start a new project here. VNB211 standalone. Okay, so we're just going to create a little project here. So first thing, you're going to go to device. So you've got a new device, it's a vibration monitor, and down the bottom of the list you'll see VNB211. So as long as you're connected to the PC with your USB cable, so it's got an M8 connector on there, which is on the right hand side of the unit. If you scan, you'll find the unit is detected with a serial number and everything else. Double click on it and you'll get it embedded into the unit, connect to it, and now we've got a connection. So let's have a look at parameters now. So first up, if you have a look at the dynamic inputs under AC, you'll see that it's actually connected to the internal sensor. That is correct, that the accelerometer is built directly into the unit. You can also add, we won't go through it in this video, but you can also add another accelerometer to it or another 4 to 20 milliamp device. So it is also quite unique in that respect as well. Okay, so the first thing we need to do now is to create some objects. So the most common one is your overall vibration, so VNB, VRMS, and time. So we've done that now. So the other thing that we want to do is you can create two diagnoses. So this one is the overall vibration in the velocity. And if we go into the P, you'll see that we've done another diagnosis now, but now it's in a peak. So an acceleration in peak. So that's pretty much all you have to do those creations. If you double click on it and go to processing, you'll see here that it's set up for a low pass filter from 0 to 1000 hertz as a default, and the warning and damage levels have also been set. So 2.8 millimeters and 4.5. So these aren't ISO 10816 standards, but they're set up fairly small to pick up small vibrations that we can do on our desktop. Normally they would be set to 4.5 and 7.1 if you're ISO 10816. So that's that first one. Our peak is here, and if we go to processing on that one, you'll see that it's set to 5 Gs for warning, and the damage is set for 7.5, and it goes up to 6000 Hz. That's the maximum that sensor can read to. So that's all you need to do there. History. So if you want to, you can actually make this a much quicker logger. So if you just click onto the top pencil here, you can get rid of that in minutes and actually go down to even 1 second if you wish. That's a very fast log rate. But it's quite a good little logger for a number of things. So yeah, why not try that? And then the last thing is alarms. So traditionally you have a warning alarm and a damage alarm. And if that's all you want, you just have to click on them, specify them, that's all they're done. If you have a look on them, you see the source, there's the two diagnosis, VRMS and APEAK. Doesn't matter which one it is, it'll alarm on either of them or both of them, and the same happens with damage. So it's got an OR gate in there and OR gate, so you can actually determine what you want to do. There's actually other alarms in there, but you can only have two. You can configure your own custom alarm, or you can do an analog as well. Okay, so once you're happy with how well it's gone, you can save it and then write it. Okay, now we've got our program running. So if we actually go to our damage level screen, you'll see there's the VRMS and there's the APEAK. Again, if I thump, you can see that working quite nicely. You can display it as, make that larger. You can do it as just a bar graph as well, or as just a graphic. And you see once the state changes, the color will also change. You can also do it as data coming through from the start, or a continuous one. And a lot of people don't use that, but it actually is a quite good tool to use. So we'll put it back onto the normal one. Okay, we can also do our spectrum monitoring. Let's see if we can get some data here. Okay, so at the moment we're on FFT. To do velocity in its true state, we need millimeters per second. And I've actually got an unbalanced weight hooked up to my demo. So if I turn that on, hopefully the machine noise doesn't code too much. You can see that we've got a nice spike, about 6.5 millimeters per second. If I get my camera, turn it on, you'll see that you can't actually read on your when you're actually doing this, because when you're taking data, it goes into a special mode. You're online. So that's quite normal. RSC3, I don't know what it stands for, but it just means that you're in monitoring mode when you're taking recordings and so forth. Let's go back. Okay, so you can actually look and expand. You're going to see all of the levels of the unit. You can see the harmonics. You can see that they're all tied together to this stage pretty much. And there's probably a bit of looseness in there as well. You can also display it in acceleration. And you can also do it in an acceleration window, which is what we typically use when we're doing a bearing diagnosis. Because we don't have specific alarms in here, we can't see it. It's not a bearing fault in here anyway, this is just purely an unbalanced situation. So let's stop that. And we can also do our time waveform. So if I click on the imbalance on here, you'll see there's quite a big difference between there. Being USB, it's not as fast as Ethernet, as you find in the other Octavis units, but it still does the job. I don't know if you noticed not before, but you can only record in the damage level screens or in time waveform. So that's the records point there, that's where that gap is. And if I stop, it'll ask me if I want to save that recording. I'll say yes. And you'll see that it's actually lodged a file, a raw data file in here. If I double click on it, and press play. As we recorded it, that's how it's going to look. You can see there's quite a few spikes in here, and that's of course due to the imbalance in that weight that I've got on the demo unit. You can also right click on that file and go spectrum, and you'll get a complete spectrum up to 6K, working quite well. Yeah, so you can see what you want to see. Yeah. I'll put it into millimeters per second, and then you can see straight away that you've got some imbalance issues at your run speed. There's no markers on this one. If you go to sub objects, there's nothing that happens in there, unlike the full Octavis system. So you do have to know a little bit of what you're doing, of course, if you're looking at the spectra. But in the damage level screens, of course, you'll have that coming up. No problems at all. That's what you really need to know. Your alarm will be high now, because these are normally closed, so both of them are actually high. In fact, if we look at the camera, you'll see the two alarms on the end there. This last one dot looks yellow in the camera. It's actually red, and there's a yellow one there. So both of those are high, reading 5.8 millimeters per second. Yeah, so you've got alarms there. So you don't need anyone to tell you that there's something wrong. There is something wrong, according to the set points that you put in there. Okay, let's just pause that for a second, and let's see if I can swap over to a bad bearing and show you the difference. So that was my balance weight with the lead slug in it. This one is a bad bearing with a crack. You might just be able to see it there through the adder race. So let's put that in. Okay. Now, you can see that's picked up a little bit of extra noise. That bearing is really bad. We actually have got an alarm in VRMS, but it is a really bad bearing. Let's just swap over to my peak. Now I didn't change that to 5G, so that's why it won't go. So we've got a set point that's too high for that. 5G is a lot of energy, so what it should be is probably 900 and 1000 millig's. So we can go into the parameters, change that. Let's change the other one first. We have to change the low first, otherwise it won't be happy. So 900 and say 1100 millig's. So let's save that. Hide it. Go back to damage level. So now you can see that I've got it at 900 and 1100. See now. There. Spectrum. Now you can see there's some quite high spikes there. Without markers it doesn't really help you that much, but you can't record it in this stage. You've got to record in here. That's my waveform. Start recording. You see the difference. So I can turn the noisy thing off now. Okay, so there's the file down the bottom here. Oops, what have I done? play that file back. You can see how much data is involved, even with a small amount of data, how much that we have here. So you can see there's quite a few impacts in here. Whilst we're waiting, we might just put it into Spectrum, and you can see that we've got some rather large spikes onto here. Hi, Chris again. A couple more things I just want to show you before I go. The history file, as you remember, we set to 1 second intervals. So if you have a look at the top here, I created 1 second, if you remember. Down the bottom here, you'll see the estimated recording time, which is 1 day, nearly 2 days at 1 second intervals. So that's pretty good. So it's actually quite a large memory. If you put it at a decent rate, let's say we put it in at an hour and 5 minutes, you'll see that you got 7,750 days. So it's not a small memory, it's actually a very large one. It's about 686,000 readings, I think, from memory. So it's yeah, quite big. Anyway, we'll put it back to 1 second. So it's back to 1, 2, 3. So before I had a few faults on that machine, and what you do have to remember is that when you get the VNB211, it came from Germany. So the unit has a real-time clock in it, and until you reset that memory, it will have the German time in it, most probably, unless someone set it before you. So basically what you need to do is to go back to Settings, go to Actions, and Reset Device, and you'll see here, Reset History. So you need to click on this, and it will reset it. If I do it now, I'll lose my history functions, but you basically need to do that. And then when it resets, it will take the PC time that you're connected to, which is, of course, very important, and otherwise none of your events will tie up with the right time. So just remember to do that, otherwise you will not get the right readings. So basically, to read history, you basically click on that clock icon, and now you can see the when I had a bad unbalanced weight and when I had a bad bearing in there. So if you click on this left arrow here, and you'll see that I've got, you can turn it on and off. You can turn the average off. The average is off on both sides, so you can see I've got a green one for the average. I don't want that at the moment, so you can just delete it. So now you've got the two trends, so an orange trend and a blue trend. So the blue one's in acceleration, the orange one is in velocity. So if I don't want to see the peak, I can turn it off and just see the velocity. If I want to see the one and not the other one, then you can do it into acceleration. So I'm sure you get the idea. And so once you get too many icons on here, too many axes on here, you can just delete them. To get them back again, you just have to start it again. Oops. And there you go. But if it gets confusing, then you can actually get it. It's not so bad with this one, but in the full-blown Octavis you can have 14 axes on there if you want. So it does get a bit confusing, so that's how you get rid of them. Okay, one other thing is back into parameters. I said about an analog alarm in there. So I've created a warning and a damage alarm here. So if I want to do an analog, just delete alarm 1, go to alarms, new alarm, click on analog. And so now you can actually have it to be either on velocity or on acceleration, but you can't have both. In the full Octavis you can have both. This one it's either one or the other. So normally you would have it on velocity because that's probably the more important one for you. So you can have it from 0 to say 25 millimeters a second, which is what the standard says, and you can have it on just your RMS. If you had the other accelerometer, you would actually have some more to choose from as well. Okay, so once you've saved that, as I save the history, yes, I saved it and I can write it. Look at the parameters, and now I've got an analog in there. So if I put the unbalanced weight back in there, start it, you can see my analog output going high. I've got an alarm straight away. So you can see the alarm there. So hopefully that was been helpful for you. If you've got any problems, please send me an email. And that'll be all for me for this session. Okay, bye for now.
IFM, close to you.